In this one, let's review solving an inequality. We have x squared minus 8x plus 12 is greater than or equal to 0. So let's go through the process of solving it. I'm going to begin as follows here. I have x squared, and then this is minus 8x plus 12 is greater than or equal to 0. So because you have a quadratic expression on the left side of the inequality symbol, factor that first. So I need two numbers that multiply together to give me 12, or whatever that number happens to be for you. The same two numbers then added together have to equal to negative 8, or whatever that number happens to be for you. That's the coefficient on x. The 12 is a constant at the end. So I can think of these pretty easily. For example, I might say 6 and 2. 6 times 2 is 12. But the problem is that 6 plus 2 is not negative 8. So that tells you the signs are not correct. So for example, make this negative and this negative. 6 negative times 2 negative is positive 12. And then negative 6 plus negative 2 is negative 8. Those check. So once you've done that step, let me zoom in. The next stage, you can factor the expression on the left side. So I'm going to put x minus 6, and then I'm going to put x minus 2. Then you mark these the opposites of these two values on the number line. Remember that the 6 and the 2 are the roots, so mark them on the number line. The opposites, in other words. So this is 2 right here, and then 6 right here. To solve the inequality, you now have to choose sample values. Let me see here. I'm going to first choose the easiest sample value. Well, to the left of the positive 2, I might choose 0. So x equals 0 is a sample value. It's easy. And I'm going to plug that into the inequality. It will either make it true or not true. That's it. That's the simple test. So when I carry that out, I'm going to do on the side, I'm going to have the following. 0 minus 6. 0 minus 2, is that greater than or equal to 0? That's our goal. So 0 minus 6 is negative 6. 0 minus 2 is negative 2. Is that greater than or equal to 0? Two negatives multiplied give a positive, so you end up with 12 greater than or equal to 0. What this tells you is the following, that beginning from the 2. And notice that at the 2, the question is, should you shade or not shade? Well, look at the inequality symbol. You see it has the greater than or equal to portion. Greater than or equal to 0, because of the equal to portion, that tells you that at the 2 itself you shade. It's a filled in dot. Like this in red is responsible for filling this, okay? And then, because the sample value is to the left of the 2, that means you shade beginning from 2 going to the left. So you're shading this way. One thing to be observed is the following. When you begin at the 2 and you shade to the left, it's as if you were going towards negative infinity. So you have to mark that, just so you don't forget it. So here you might, for example, put the following in this position. I'm going to put over here is negative infinity. So from negative infinity up to 2, any value from there will solve the inequality. Then you have to test the sample in the middle. So for example, since this is 2 and 6, let me grab a sample value in the middle right here. Let me erase those little marks. So for example, I might choose x equals 3. I'm going to plug that into the inequality to see whether the inequality is true or not. So let me do that next right here. You may want to separate the space, just the way I'm doing here, draw some vertical lines. 3 minus 6. And I'm going to do 3 minus 2, and I'm checking, is this greater than or equal to 0? 3 minus 6 is negative 3. 3 minus 2 is 1. Is that greater than or equal to 0? Well, negative 3 times 1 is negative 3. Is that greater than or equal to 0? This is definitely false. So for that reason, the portion between 2 and 6 is not included in the solution, okay? So, not included. Don't shade between 2 and 6, in other words. Let's finish up here. We have to do also the portion from 6 to positive infinity. So, I'm going to grab a sample value, like for example here I'm going to say x equals 7. I'm choosing that as my sample value to plug into the inequality. So when I do that, I will have 7 minus 6, and then 7 minus 2 greater than or equal to 0. 7 minus 6 is 1 positive. 7 minus 2 is 5, greater than or equal to 0. So is 1 times 5, which is 5, greater than or equal to 0? That is definitely true. So let me erase this here. Since that is definitely true, that tells you that beginning at the 6, you're going to shade to the right also. That means any value from the 6 going towards positive infinity solves the inequality. So 6 is over here, and then you go towards positive infinity. Again, you're going to shade with the 6 here because the equal to portion is present in the inequality symbol. So once you have all of these pieces in place, Notice that our solution is broken into two separate pieces. Let me emphasize this. On the left over here you have negative infinity up to 2. That's one of the pieces. From negative infinity up to 2, you skip the middle, and then you go over here that says 6 to positive infinity. That's the other piece. You got to account for both of them when you enter your solution. So let's write the solution. So the solution is final form will look like this. You read the number line. When you read the number line and you write the solution, be careful. Read the number line from left to right. Okay? So remember that means the following. Negative infinity, 2, gap, 6, positive infinity. When you write the solution, you're reading from left to right. So when I do that here, it'll look like this. Please take a look. I will have negative infinity, comma. Next to negative infinity or positive infinity, always parentheses. It's not a number, it's a concept. You can't ever reach it, in other words. So then you put comma, and then after that you put 2. Next to the 2 you put a bracket, because above the 2 in the number line you see you have a filled in dot. To indicate that you need to skip the portion that goes from 2 to 6 on the number line, you put U for union. Then you resume on the other side of the gap. That value there is 6. Again, the 6 is included, so you put a bracket, comma, and then the 6 goes, well, you begin at the 6 and you go towards positive infinity. So you put parentheses around positive infinity. So this is the interval notation solution. You enter this in a box here, so you write parentheses, negative infinity, 2, bracket, U for union, then you put here 6, comma, positive infinity. And I want to point out some of the things here before I go. These are separate examples of what might happen, okay? So specifically, imagine you solve an inequality and you mark the number line, and the number line looks like this. So you mark a number line, and you find that it's values between these two. Notice that this is like, say, 2 and this is 5. I'm just making these up. And notice that the shaded portion is the one that you find solves the inequality. The 2 and the 5 themselves do not solve it because they have holes above them. So you would indicate this by putting 2, 5 in interval notation, and then parentheses, parentheses. The parentheses right here, let me emphasize this. You see how this is an empty hole? That means here you put a parentheses. You see how on this side, this is also an empty hole? That means here next to the 2 you put a parentheses. A couple other possibilities, take a look. Imagine you solve an inequality and you end up with something that has this form right here. For example, this one is included, this one is included, and then you shade the portion between them. Let me make up some values to go with them, okay? So imagine this is like -3 and this is 7. So to write this in interval notation, you would put -3, 7. Because above the -3 right here, that's included as part of the solution. That means when you write the interval notation, you're going to put a bracket. Above the 7, imagine that's shaded on the number line. That means here, next to the 7, you put a bracket. Lastly, let's take a look. Let's do one more. I want to make sure I show enough examples. Imagine that you solve an inequality and you find that it's values that solve that look like this. Okay, you begin, for example, over here and then you shade to the right. And you begin over here and then you also shade to the left this way. Okay, so these are the solutions right here. Imagine these numbers right here are -4 and 8, positive as an example. So when you write this in interval notation, let me zoom in so I can focus on this. Remember, over here is negative infinity, and over here on the right side is positive infinity. So when you shade, it's going to look like this. You're going to go from negative infinity, comma, to -4. Notice the -4 itself, for example, is not included because there's a hole above it. So because you see this is a hole, that means next to the -4 you put a parentheses. To indicate jumping over the gap, you put U for union, and then you resume on the other side. Again, above the 8, imagine there's a hole, it's not filled in. So for that reason, this is a hole, I'm going to put parentheses, and I'm going to write my number in there. 8, comma, and it goes towards positive infinity, so you put positive infinity. On the left side, go back there for a second, next to negative infinity, you should put a parentheses. So it looks like this. So the key point is be very careful, especially with these right here. Let me erase them and do that one more time. Parentheses, parentheses, because above both you have holes, not solid filled in dots. And that's all of the work. Thanks so much for watching. I'll see you in another one.